Hello everyone, welcome back. We're going to talk about flowcharts, functions, and a problem-solving technique called functional decomposition. Here we go. Flowcharts. There are three types of charts that we can talk about. There are obviously more charts that we can talk about, but these are the three that we're going to focus on. Number one, they're called system flowcharts. We often use these to describe algorithms, how they work from start to finish. We can also describe how a system will solve a problem. Secondly, we have a data flow diagram, or a DFD. They're used to show how a program or system processes data between multiple destinations. And a structure chart, a chart that focuses on relationship, hierarchy, organization of a system. Think of like a family tree. That could be a structure chart. And of course, there are more charts like object-oriented programming uses a concept called UML, and web design uses stuff like wireframes. So, in senior computer science at Williams, we're going to talk about flowcharts like this, where we're going to keep rectangles for any task, variable creation, input, processes like doing arithmetics or having an output. Whereas diamonds, we're going to use that for decisions like if statements are branching, and we're also going to use it for loops. So in this situation here, we have a variable called count is equal to 0, and this variable sum is going to equal to whatever sum it was before plus count, and then count is going to go up by 1. If the count is greater than 5, yes, it continues on to code. If not, we're going to loop back up to the top and add the count to the sum and so forth, and this is going to continue on until count is greater than 5. So let's look at some more flowcharts here. We have a decision on the right side where we have if max is greater than 0, we're going to output positive. If this variable max is less than or equal to 0, it's going to say not positive, and so forth. And that's how a flowchart would work when you describe code in a flowchart. Let's talk about functions. Function is an example of a subprogram, and it's a block of organized reusable code that is usually used to perform a single and related action. And there are 4 reasons why we create functions. Number 1, clean code. We want our code to be organized into these functions so that there is like structure and organization to our code rather than having a one long code that is solving all the requirements of a problem. We can break down a problem into multiple requirements and write a function per the requirement that we need to code so that there is organization and structure. Secondly, we often use functions to express algorithms. When we learn about algorithms, we often trap them in a function so that we can provide the proper inputs that an algorithm might need, and then we can output what the algorithm should output. For example, if you wrote a linear search algorithm, you can put or create a function called linear search, and it should behave exactly like what a linear search algorithm would do. And next is reusability. If you have a really nicely made function that is well tested, what you can do is in a future program, you can copy that function over to your new program, right? Because if we wrote a gigantic long piece of code without any organization, you can't really copy pieces from that program. So having functions allows us to use reusability. And throughout even a bigger program, which is composed of multiple functions working together, these functions are callable again and again and again when you need that certain behavior or feature to be used throughout the program. And lastly, it should be single serving. A function shouldn't solve multiple requirements, but rather a single requirement. That will make our life easier when testing and just making sure that all of our requirements are solved. So speaking of functions, there is a very rudimentary design philosophy or a way to solve problems by doing something called functional decomposition. As in, if we take a grand, large problem, how can we decompose what we need to do to solve that problem into different functions? So what is functional decomposition? It is a method of breaking down a problem to smaller components so that the solution is the total sum of all the smaller components working together. And the benefit is when a problem gets decomposed into the simplest components, the program is easier to create. Like you just have to write all the components, integrate them all together, and then you have a fully working solution for the problem that you started with. And having simple components like functions allows us to do really nice unit testing. So it really sets up good unit tests so that we can do our positive, negative, boundary test on those units, so forth. So, if we were to do functional decomposition in real life, and we were trying to do like very like online distance education information system, that sounds scary. That problem of having a system that creates a distance education information system, right? But if you decompose it, if you break it down into smaller parts, that means you can work on these one at a time, and once they're all finished, then you can start to worry about integrating them all together. So for this kind of system, we might need a student management system. We might want to modify their profile and then even add in features like deleting a profile. We might want to manage their transcripts, create their grade, create a transcript, and all that. And if you can see that when we start focusing on different parts, and you're working on just one component, you don't need to worry about the other parts. As long as you finish the component you're working first, and then you can move on to the other components we have listed down. Of course, functional decomposition is not a simple thing to do because you need to know how to decompose, what should be decomposed, and how far of a decomposition that you can go. So even in a simpler term, we can talk about doing functional decomposition when we're making a cheeseburger. Okay? So when we talk about the act of making a cheeseburger, we can decompose that into these components. We need to prepare and slice tomatoes, onions, and pickles. Okay, we need to wash the lettuce. We need to toast the bun. We need to cook the burger patty. We need to melt the cheese on the patty. We need to apply ketchup, mayo, mustard on the top bun, and we need to place the patty on the bottom bun. We add the tomatoes, onion, pickles, and lettuce on top of the patty, and then we place the top bun to completely make a cheeseburger, right? But if you go line by line by line, if you go in order, that was a decomposition of the whole problem of us making a cheeseburger. And more in coding sense, we can create a restaurant reservation app. And the major functions can be creating a calendar system database, reserving a table, like that can be a function where we get to reserve a table. We should be able to cancel booking and create a reminder system. And then since these are our major functions, we can even decompose that further, right? We can receive a party size if we are reserving a table. We also need to receive a time and date. Then once we have the party size and the desired time and date, we need to compare that with previous reservations to see if the reservation is possible with our given parameters. If possible, book the date with the name and a phone number. We need to grab those two values. If not possible, we can suggest available time within the plus minus 3 hours they've requested, or we might have to ask for a new time and date altogether. And this was just a single decomposed function from our overall problem of creating a restaurant reservations app. And in that function, we had one called reserve a table, and we even broke that or decomposed that further down to know that this major function is going to require even smaller functions, multitude of smaller functions to have that major function or feature in this app. So that was it. Thank you so much for watching. We talked about flowcharts and different charts, how visuals can help us organize things. We talked about functions, how functions allow us to have reusable code. It allows us to express algorithms, allows us to create clean and organized code. And we also talked about how functions should be single serving. And all of this allows us to test our functions easier. And we talked about a minor programming technique called functional decomposition, where we get to break down a larger problem into smaller sub-functions that we can generate so that we can simplify our programs in the future. As always, thank you for watching, and stay classy.